This practice problem is a predict the product question. It's open-ended in that we do not know what the mechanism is. So the question asks, predict the major product of the following reaction. So this is really good practice for kind of like the end of chapter 7 material, because we're trying to figure out what the mechanism is for our different reactions. And then from there, we have to apply what we know about the mechanism to predict the final product. So I'm going to walk you guys through this example, kind of using the same process that we've used in lecture to kind of think about what type of a reagent do we have, what type of a substrate do we have, and then what's the mechanism going to be. So in this example, we have as our reagent sodium thiolate. Sodium thiolate has a positive charge for the sodium and a negative charge for the sulfur atom. So we essentially have this molecule as our reagent. So when we take a look at this, we can kind of immediately tell that it's strong and small. Strong because it has a full minus charge, and small because it only has 2 atoms. The tricky part is remembering that thiols and thiolates are generally nucleophiles only. This is because their conjugate acids are kind of stronger acids than certain other molecules that are considered bases as well. So thiolate is a nucleophile only, and it's a very weak base. So if you have a reagent that's a nucleophile only, we can narrow our reaction mechanism down straight away and know that it's going to be a substitution process, SN2 or SN1. So to really narrow it down after that, we have to take a look at what our substrate is. So our substrate has an iodide as the leaving group. Iodide's a pretty good leaving group. And it has an alpha carbon that's got 2 R groups attached to it. So it's a secondary substrate. The beta carbons don't have any steric hindrance at all. So that's kind of significant because it means it's kind of more like a true secondary substrate. So if we have a secondary substrate and we have a reagent that is a strong nucleophile only, that is going to tend to favor an SN2 process. Generally, when you have molecules that are strong nucleophiles, that'll help favor the bimolecular process. Secondary is a little bit sterically hindered for SN2. So it'll probably be slower than if we say have like a primary substrate, but it can happen. In the actual lab, we might speed this reaction up by like applying heat to it, for example, and that could, in theory, make it go faster. So an SN2 process, even though we have a secondary substrate. And again, this is because we have a nucleophile only, so elimination processes are not at play. So in this case, we want to think about how will this SN2 mechanism affect our substrate and what type of product will we get out? So for SN2, we know that everything's occurring at once. So it's a simultaneous or concerted process. And whenever you have that concerted process, there's a key stereochemical concern to think of, and that is that with SN2, we have the backside attack and inversion of the alpha carbon. So stereochemically, we know that the carbon that bears the leaving group is going to get inverted. So let's take a look at our products. We have elimination products that you can cross off right away. Those are there to kind of distract you in case you didn't recognize that the thiolate was a nucleophile only. Next up, let's take a look at molecules 1, 2, and 3. Molecules 1, 2, and 3 all have the thiol replacing the iodide, but notice that molecule 2 does not have inversion. So I'm going to cross that off because the alpha carbon is not inverted. And we know that's a key requirement for SN2. So that leaves us with molecule 1 and molecule 3. And the key here is to take a look at the methyl group that's coming off of the ring. In 1, it's dashed, and in 3, it's wedged. And so this is kind of a area that some people struggle with a little bit, is that what happens to any other chiral centers that are present in the molecule? And the answer is that they stay the same. So we can cross off 1. because the only carbon that gets inverted is the alpha carbon. The gamma carbon that bears that methyl group that's wedged wouldn't be impacted at all. It just kind of stays exactly as the same. And the reason for that is just because the nucleophile is not bothering that carbon. It's only attacking the alpha carbon. And that's why only the alpha carbon is inverted. So our answer to this question is 3. If we take a look at our answer choices over on the left-hand side, we can see that we have options of 1 only, 2 only, 3 only, a mixture of 4 and 5, and a mixture of 2 and 3. So after our discussion, we know that the answer is C.